Hello, welcome to this video. In this video, let us take one more problem on reciprocating compressors. Let us read the problem. A reciprocating air compressor has 5% clearance. So, we can write that 5% clearance means VC is 5%, that is clearance is 5% of swept volume, or we can write that VC is 0.05 times Vs, or it is also can be written as Vc by Vs is equal to 0.05. This we have called it as clearance ratio. So, therefore, the value of C is 0.05 with a bore of 25 centimeters. So, diameter is 25 centimeter. Now, the diameter in terms of meter is 25 into 10 power minus 2 meter. So, that is 0.25 meter. And length of the stroke. So, length is given 30 centimeter. So, 30 centimeter can be written as 0.3 meter. The compressor operates at 500 rpm. So, capital N is equal to 500 rpm. The air enters the cylinder at 27 degrees Celsius. So, T1 is given 27 plus 273 is equal to 300 Kelvin, and pressure P1 95 into 10 power 3 Newton per meter square, and discharge. So, discharge means delivery pressure is given. So, P2 is 2000 kilopascal. So, kilopascal means 10 power 3 Newton per meter square. N is equal to small n is equal to 1.3 for compression and expansion process. Determine first one, the volumetric efficiency. The first question is we have to determine volumetric efficiency. Second question, volume of air handled at inlet conditions. So, since we are talking about clearance volume, this will be VES, effective swept volume at inlet conditions, all right, and the power required. So, power required, and fourth one is the mass of air handled or mass of air discharged. So, mass of air discharged, and we must find it out in kg per second. Now, let us solve this problem. Let us go for volumetric efficiency first. I think we know all the terms in volumetric efficiency. So, volumetric efficiency is 1 minus C Rp power 1 by n minus 1. Okay. So, 1 minus 0.05. Now, this Rp is 2000 by 95, that is P2 by P1. So, 10 power 3 cancels out. I am not writing that. 1 by 1.3 minus 1. 1 minus 0.05 into 2000 divided by 95 power 1 by 1.3 minus 1. That will be 52.89 percentage. So, the answer is 52.89 percentage. Now, keeping this volumetric efficiency, what we can do, volumetric efficiency is given by effective swept volume divided by swept volume. This equation can be used. Now, do we know two of this? Then we can find out the third one. So, swept volume can be determined. I will go for swept volume first now. Now, swept volume is what? Pi d square by 4 into length. Okay. Now, we are I am not writing in meter cube per second. Whenever it is required, let us write it that way. So, for now, let us calculate VES in terms of meter cube. So, pi d square, pi into 0.25 square pi d square divided by 4 into length is 0.3. Okay. Shift pi into 0.25 square pi d square into 0.3 divided by 4, 0.0147. Remember, this is in meter cube. If you want it in meter cube per second, we will have to multiply this by RPM and divide by 60. Okay. This is our Vs in meter cube. Now, I think in order to get the idea, we should have drawn a PV diagram. I will draw PV diagram with clearance volume. PV diagram will also carry weightage in terms of marks. So, we will have to draw that. So, this is our 1 to 2, then 2 to 3 is delivery, 3 to 4 we are coming back to the initial point, 4 to 1 is suction, and 1 to 2 is compression. Polytropic compression, constant pressure delivery, polytropic expansion here, then pressure constant process. Now, we know volumetric efficiency is 52.5289 must be equal to VES divided by Vs. We have already found out 0.0147. Okay. Now, 0.5289 into 0.0147, this will be our VES, 7.77 into 10 power minus 3. VES is equal to 7.775 into 10 power minus 3 meter cube. Okay. So, that will be our VES. Now, once we have found out these values, now this is PV diagram. Okay. Once we have found out these values, I mean this value VES is in fact the value which is with respect to inlet conditions. So, the volume of air handled with respect to inlet condition is VES, that is 7.775 into 10 power minus 3. So, we can also write this in terms of meter cube per second if you want, 7.775. All we have to do is multiply with respect to RPM, but multiply with respect to RPM, that is N, and since this is in per minute, we will have to divide by 60. This will be meter cube per second. Okay. So, answer into N 500 divided by 60. So, 0.06479 or 648 we can write, 0.0648 meter cube per second. Similarly, Vs can also be written in terms of per second. So, Vs is we can also write it in into N by 60. Now, 0.0147 into 500 by 60. So, 0.0147 into 500 divided by 60, 0.1225 meter cube per second. So, that will be swept volume. Okay. Now, we have written VES and Vs as in meter cube as well as meter cube per second. Now, let us go for power, but before going to the power, let us sort this out. Like we know for power, the equation is what? Work transfer is equal to N by N minus 1 into P1 VES and then RP power N minus 1 by N minus 1. Is there anything we need for this? I think for now, N is known to us, so we don't have problem. 1.3. So 1.3 divided by 1.3 minus 1 into P1 is 95 into 10 power 3, and VES will have to substitute it in terms of meter cube per second, then only we will get power. All right. So this will be power. So I am writing this in meter cube per second. Remember this, if you substitute in Newton per meter square and this in meter cube per second, this meter square goes off, and Newton meter per second, which is nothing but joule per second. Joule per second is watt, which is nothing but power. All right. So Vs is therefore 0.0648 into this Rp power is Rp is 2000 divided by 95. So 2000 is the delivery pressure divided by 95. Both are multiplied with 10 power 3, that will be cancelled out, and this will be again 1.3 minus 1 divided by 1.3 minus. Okay. Now let us calculate this. 1.3 divided by 1.3 minus 1 multiplied by 95 into 10 power 3 into 0.0648 into 2000 divided by 95 to the power that is 0.3 divided by 1.3 because that is 1.3 minus 1. I am just substituting directly minus 1. So that will give us 27.21 into 10 power 3 watt. 27.21 into 10 power 3 watt. Or we can say that it is 27.21 kilowatt. Okay. Now we have answered the question of power. Last one is mass discharged in kg per second. Now what do we mean by mass discharged in kg per second? We will have to find out the mass here. I mean, the equation we should be using is not VES, we should go for V2 minus V3. So at pressure, so we'll use this equation PV is equal to MRT. We'll use the equation PV is equal to MRT, but remember PV is equal to MRT, but we'll use it at delivery pressures, right? So it should be P2, and this V2 is not just V2, this is air handled at this pressure will be V2 minus V3 is equal to M is constant, R is constant, and this must be T2. So remember, if at all you want to find out the value of mass, we must be knowing this, and this is known to us, and temperature. So only when you know all this, then we can find out this, correct? So P2 is known to us. P2 is 2000 kilopascal. So 2000 into 10 power 3 is P2. Okay. This will keep it blank for now. Then mass is the one which has to be found out. R is 287 joule per kg Kelvin. So this has to be in kg. This has to be in joule per kg Kelvin. And temperature has to be substituted. So once we get this T2 and V2 minus V3, I think we shall be able to find out the mass. Okay. This has to be in Kelvin. So the unit is balanced joule on the right side, and on the left side Newton per meter square, and the volume is in meter cube, Newton meter here. So that is joule. Okay. Now let us find this out. Now let us find what we require. So T2, how do we find out T2? So P1 process process 1 to 2 is P1 V1 power n is equal to P2 V2 power n. Okay. So, we do not want we want the pressure and temperature ratio because we know pressure. So, let us eliminate volume from here. So, PV is equal to MRT. In place of volume, I can write MRT by P. Okay. Now, what do we mean by MRT by P? In place of volume, I can rewrite MRT by P. But however, MR cancels out. So, I am writing only T by P now. So, P1 in place of, I am substituting this in equation 1 if you want to call it as. Now, T1 by P1. Even if you substitute MR here, MR on the right side also cancels out. I am neglecting this. So, T1 power n, P1 power n. So, P2, T2 power n, P2 power n. So, in place of V2, we have just substituted T and P. So, this will be T1 power n. If this goes to the denominator, so P1 power n and this will be P1 power minus 1. If you add the power, it will be P1 power n minus. So, similarly, T2 power n divided by P2 power n minus 1. So, we are interested in T2. Let us simplify it for T2. So, T2 is equal to P2 by P1. Okay, P2 will go to the left, P2 by P1 whole power n minus 1 and T1 let us bring it here T1 power n, or we can write it like T2 by T1 is equal to P2 by P1 whole power n minus 1 by n. So, that is the equation. I think now we can find out T2 is equal to, we know the value of T1. So, we know the value of T1. T1 is 300 Kelvin. So, T1 is 300 and this RP is, P2 by P1 is 2000 divided by 95, 2000 divided by 95 whole power 0.3, that is 1.3 minus 1 divided by 1.3. Now, let us solve this. I am just going to multiply the other term directly. So, 2000 by 95 to the power 0.3 divided by 1.3, this should be multiplied by 300. So, 606 Kelvin. So, T2 is 606 Kelvin. Now, we got this T2 here, I will substitute this T2 back here. Now, what is that? V2 minus V3 is what we want now. So, similarly, let us go for the other term, that is the other term is what? V2 minus V3. Now, look back here, V3 is clearance volume. Now, V3 is clearance volume, correct. So, this is clearance volume. Now, clearance volume ratio we know, correct. So, clearance volume ratio, using that let us go for clearance volume is from here, from this equation, clearance volume is how much? 0.05 percentage of swept volume. Therefore, we can find out the clearance volume. Now, 0.05 times of Vs means 0.05 into 0.1.1225. So, that will be 6.125 into 10 power minus 3. 6.125 into 10 power minus 3 meter cube per second. So, let us no, we will keep it in meter cube. So, not this equation, we will use meter cube, but because there we want meter cube, all right. So, Vc is 0.05 into 0.0147. So, that value will keep. So, in terms of meter cube, 0.05 into 0.0147. So, that will be 7.35 into 10 power minus 4. meter cube. Vc is nothing but V3. Okay. So, we want V2. Once we have V2, V2 minus V3 we can do. So, how do we find out V2? The same ratio. See, process from process 1 to 2, we have ratio of P1 V1 power n is equal to P2 V2 power n. So, using this ratio we can find out I think V2, because now we have P1 95 into 10 power 3, V1 95 into 10 power 3, and then we have V1, do we have it? P1, V2 we have it, no, V2 is the unknown which we will have to find out. I think we can find out the effective swept volume is we have, effective swept volume we have, swept volume we have. Now, effective swept volume is from here to here. Let us check what we can find out. This is our effective swept volume. Okay. This is our effective swept volume. Then this total will be our V1. Remember, from here to here that will be V1, and the swept volume is from V3 to V1. So, this will be our swept volume. Now, see here V1 can be written as clearance volume plus swept volume. So, that is there with us. So, clearance volume we have 7.35 into 10 power minus 4, 7.35 into, so this is not necessary for now, I mean we will come back to this. Now, we can write V1 is equal to clearance volume plus swept volume. Now, clearance volume is 7.35 into 10 power minus 4, 10 power minus 4 plus Vc is 7.35 into 10 power minus 4, and swept volume is 0.0147, 0.0147. Now, let us calculate this answer plus 0.0147. So, that will be 0.0154. So, V1 is equal to 0.0154 meter cube. Now, we have got V1. Once you have V1, we can now find out V2. So, P1 V1 power n is equal to P2 V2 power n. P1 is 95 into 10 power 3. V1 is 0.0154, power n is 1.3, n is 1.3, correct? Yes, minus P2 is, is equal to P2 is 2000 into 10 power 3 into V2 power 1.3. So, we know that this 10 power 3 cancels out. We will find out 95 into 0.0154 power 1.3. Now, alpha equals 2000 into unknown is x, alpha x power 1.3. So, now let us shift, solve for x is equal to 0. We will have 1.477, that is the value of V2, 1.477 1.447. I will cross verify, shift solve for x is equal to 0. So, that 1.477 into 10 power minus 3 meter cube. I think now we have Now we have this V2 minus V3. Now what is V2? 1.477 into 10 power minus 3 minus this V3 we have found out, that is V3 is equal to clearance volume. V3 is 7.35 into 10 power minus 4. 7.35 into 10 power minus 4. 7.35 into 10 power minus 4. Now let us solve this equation. Left side I will solve it first. So answer is this minus, I am solving the first within the bracket, 7.35 into 10 power minus 4. This must be multiplied with 2000 into 10 power 3. So on left side we have 1485.44. On left side we have 1485.44, and on right side we have this m into 287 into 606. Now I think mass should be 1485.44 divided by 287 into 606. 8.54 into 10 power minus 3. So the answer will be 8.54 into 10 power minus 3 kg. Actually, we were supposed to get this in kg per second. Had we substituted this V2 minus V3 in meter cube per second, we would have got this in kg per second. All right. Anyhow, we can also do this by multiply this with n and divide by the 60. So that will be n is 500. N is 500 divided by 60. So the answer into 500 divided by 60. So 0.071 kg per second. So whatever we are doing here is in kg per second, we can write this. All right. Thank you.